Hi and good evening. Okay, for the lab FPGA, I'm grouping with Nur Anis Amira, while my name is Ainul Huda binti Muhammad Razikin. Okay, for explanation about lab 1 will be explained by Nur Anis Amira, while me will explain about lab 2 FPGA.
Assalamualaikum warahmatullahi wabarakatuh. I'm Anis Amira binti Muhammad Kamsani. I want to present about the Lab 2 7-segment counter. For the introduction, Altera DE2115 board is a development board that has been announced by Thoracic that features Cyclone for a device. It is one of the FPGA development kits designed for testing and development of the Altera Cyclone FPGA family. FPGAs have been achieved wide recognition in the electronic industry because it can quickly design into the virtually any circuit. Specifically, the E2115 board hardware and Core2 software are used throughout this lab. The DE2115 board features an effective cyclone for FPGA chip. All fundamental components on the board are connected to the pins of this chip. The DE2115 board comprises a sufficient number of switch, LEDs, and 7 segments display. For the result of the task 1, that is half adder, the VHDL description for half adder is done by Core2 software. The coding consists of the entity and architecture description, while in the architecture description comprises of appropriate expression for the output accordingly. The coding is compiled and run successfully as no errors involved. Then the schematic block diagrams on half adder is created and followed by the waveform as the result. And for the task 2, that is requires us to design a counter using on the DE2115 development board and a counter that runs in different speed. A clock divider must be created to design variety type of the frequency. First step is to design the divide underscore 10 as given. Next, to design divide underscore 50. For the further step, it needs to be done is followed by the designing clock counter. The count 0099 need to be designed before program it into the DE2115 board. As the result, the output of the program is observed on the DE2115 development board. The 7 segments showing the output result of the counter that runs with different frequency using Core2 software. For the discussion, the implement the counter at high and low frequency clock and show the output in the 7 segment. At high frequency clock, the speed of the output of the counter clock showing fast speed, which the counter of 0099 changes with high speed depending on the value of frequency assigned. While at low frequency clock, the speed of the output of the counter clock showing slower speed, which the counter on 0099 at the 7 segment change with low speed depending on the value of the low frequency assigned to it. As the result, the high frequency clock produce high speed of its counter. The low frequency produce the low speed of the counter. The component instantiation is a statement that is used to connect the element in a circuit. Thus, it is used in count 0099 to connect all the elements that contains in it from the smallest part in it till the outer part. Hence, all the elements that are already declared can be connected to each other, forming a complete circuit. While process statement is used to make sure the count 0099 can execute all the different process concurrently. And the process statement of the in the SECDEC and clock counter, the clock counter and SECDEC codes are implementing behavioral star combination design. For SECDEC process statement, they are using case statement, while the clock counter is using if statement. Theoretically, case and if statement are similar. where option on choosing between execution of alternative sequence of sequential statement are allowed. The selection made is what makes the both different. Furthermore, the if statement that use a process statement of clock counter, the selection is made for one or non-alternative sequence for execution. So the case statement that use on process statement of set that the selection is made only a single expression for execution. Besides, the list of alternatives include on the case statement begin with the reserved word are in sequence with the other sequence. In conclusion, this report taught us on the implementation of FPGA learning on the FPGA development board. Some errors happen during compilation due to the unwell managed folder creation, causing to the result between desired. Hence, we must follow the rules of creating program using Quartus 2 software. This lab has helped us as students to get familiarized with the FPGA DE2115 board and the Quartus 2 software very well. Thank you.
For Lab 2 FPGA is about LCD display. In this lab, we use firstly DE2115 FPGA board for VHDL display program. Second thing is we use Quartus 2 software, which is the function of Quartus 2 software is for analyzing and synthesizing of the DE2115 board. Okay, so the objectives of this lab is firstly to use the LCD to use and familiarize the LCD display on DE2115 FPGA board for VHDL display program, and secondly to modify the program with a different display output. Okay, for the methodology of this lab firstly we have to create a new project in the wizard and then name it as LCD display as the given description in the lab manual. Then we need to copy all the coding in the lab manual and paste it in the Quartus 2 software. Okay, this is the lab coding. Which we need to copy, and sometimes, not sometimes, but based on our experiment for the first time, we had an error. But after overcome the error, we get the result. Okay, so this is the coding of this lab. Okay, the result is we want to make an LCD display on the LCD display the name of each day, which is Monday, Tuesday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Here we are, which had we get the result as what we want. But before that, sorry, I had missed the Cyclone IV layout. Okay, this is the Cyclone IV layout, which help us compile the VHDL file and not the assignment for the LCD display. Okay, so this is the result of the designated code on that displayed on the LCD. Okay, so this is BBT controller. This is Monday, this is Tuesday, this is Wednesday, Thursday, Friday, and Saturday and Sunday. Okay, after we had get the result of the day displayed on the LCD, next we are assigned to make differences or edit the coding to code on the LCD display to redesign the coding so that the LCD display will show January to December, the name of the month in a year. We just use the same coding, but we just need to change the HD 4478 character and character data has values from January to December, then assign switch based on binary numbers to display the result on the LCD. So this is the coding we use to successfully answer the assignment given in this lab. Okay, and this is the coding we use. And lastly, we get the output of the modified code as what we want. Okay, January, February, March, April, May, June, July, August, September, October, November, December. So that's the result of the month displayed on the LCD. As the conclusion, we can say that modeling sequential circuits element with VHDL is an interesting application in this lab session. At first, it seems like quite hard to make it possible to generate the code, because when we copy all the code given in the lab manual, it tends to be a lot of error. But at last, to write up the code of each task, generate their block diagrams and simulate the waveforms for their results successfully. For the exercise given, they need to reuse the 7-segment display code as well as the use of shift registers and clock dividers. To wrap things up, this lab took around 2.5 hours to be accomplished. Extremely minor challenges were confronted. Somehow, all goals have been achieved successfully. So that's all from Nur Anis Amira and me, Ainul Huda binti Muhammad Razikin. Thank you.